Hey, what's up, guys? This is Nitish from #Rudy. So, welcome to my YouTube channel. Today, I am going to teach you about motion. So, this video will be in parts, different parts. Okay, so first part will be of 10 to 12 minutes. So, this is, I guess, chapter number first of class 9th. Yep, motion. So, let's get started. Yeah. So, our chapter is motion. Okay. Now, what is a motion? Just let's have a simple definition of motion. When any body changes its position with respect to time, in a given time, if a body moves some distance, I mean, first it's stationary and then it's moving. So the position, that's the main thing. The position, if the position is changing with respect to time, then it is called motion. Okay, a body is said to be in motion when its position changes continuously with respect to a stationary object taken as reference point. पॉज करके नोट कर लेना. ओके, ठीक है. फॉर एग्जाम्पल, जस्ट एन एग्जाम्पल, दिस अ कार. ओके, when the position of car changes continuously with respect to stationary object, like suppose there is a house and in front of the house the car is standing. Okay, parking. And when the car will move, then its position will change with respect to that house, with respect to that tree which is in front of car, behind the car, or somewhere else. Okay, so we say that the car is moving or that the car is in motion. Let's take an example to understand the meaning of motion more clearly. So here's the picture which I drew just now. There's a car and there's a house. Okay, the car is moving far from the house, or we can say towards the west direction or east direction, somewhere. Okay, just it's moving far from the house. But if there is a person or anyone, no, not anyone, just the house. Okay, बस एक घर है, अंदर कोई हो या ना हो फ़र्क नहीं पड़ता. अगर घर में से कोई कार को देख रहा है, ओके, तो उस बंदे के रेफरेंस में ये कार दूर जा रही है. ओके, देन that guy or this house will be the reference point and this car will be in motion. Okay, so this will be the direction, this will be the house, and now it proves that the car is in motion in this direction. Okay, yeah. And now there's a fact of point in this chapter motion, that if the body or any object is moving slowly, not too much fast, okay, then we can observe it very clearly. I'm sorry, I'm wrong. We can't observe it clearly. Okay, we can't observe it clearly. But if the body is moving just opposite of that, I mean, if it's moving too fast, then we can observe it clearly that it's a moving body, because in reference to our eye, that body is moving just matlab, I mean, just it's acting like it can be visible. Let me give an example. When you see a watch, okay, there are three. One is second, minute, and hour. Okay, when you see the second one, it moves like tuck 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 tuck. You can see it very clearly, but not the hour one. Why? Because it moves too slowly to be visible by naked eye. Okay, yeah. So this is an example, just a fact. Okay, so in this chapter our next topic will be distance and displacement. So before distance and displacement, let's talk about vector and scalar quantity. Okay, so first is scalar, is the spelling, and second is okay. So what is an scalar quantity? Scalar means when a moving body or something else which has a magnitude as well as a direct, I'm so sorry, the moving body which have only magnitude but no direction. For example, let me give an example. Okay, so there's a car and it's moving. Okay, so when the car will move, it will give some speed. Okay, but instead of seeing its direction, we will see only its speed. Why? Because speed is a Scalar quantity, right? While in vector quantity, we will not see only the speed, but only the magnitude, but also the direction. For example, the same car is moving forward. Okay, suppose this is east. Yep, this is east. Okay, so this is moving in east direction with a positive speed of 45 kmph. Okay, so it's moving in 45 kilometer per hour. This is the speed, but we are also seeing its direction. So we will say that this car is moving with 45 kilometer per hour in the east direction. So when this will be the uh, proper definition, then it will be a vector quantity, which we called it as velocity. Okay, it will be velocity. So just now we studied about scalar and vector. So in scalar, the same term called speed, and vector, the same term called velocity. Okay, just the main difference is that in speed we will see only the magnitude, but in velocity we will see magnitude as well as direction. What this means? This means that when the body is moving forward, okay, if we take forward as positive, then if the body is moving backward, then we have to take this positive sign as negative. This negative and positive signs define the direction. Okay, so we have to use this is velocity and this is speed. So speed is a scalar quantity because it only has magnitude, not direction, and this is vector quantity because it has magnitude 45 as well as direction plus or minus, okay, forward or backward. So now let's come to displacement and distance. So in the case of distance and displacement, so what is a distance? So we can say that the distance traveled by a body is actual length of the path covered by a moving body irrespective of the direction in which the body travels. Okay, it means that we will not see the direction of the body, that where it is going. We just want to know in the distance that how much kilometers, how much meters, or how much it traveled. Okay, suppose this is a path, okay, and the car is here, it's moving like this, like this, like this. Okay, it started from here, it went here, and it went here, and it reached to hit its starting point or initial point. This is if A, and this is B, and this is C. Okay, so suppose that this distance is 4 km, 5 km, 6 km, then it's clearly visible that this car has been traveled 4 plus 5 plus 6, so this will be 15. So it's clearly visible that the distance traveled by the car is 15 meter, irrespective of the direction that it traveled from where to where to where, and irrespective of that it started from A and it end to A. Okay, but this is not the same case with displacement. So let's talk about displacement in the same direction. So it's visible. Okay, now let's talk about direction. Direction, the first direction is towards the east. Okay, second is west, third is north. Okay, so in displacement, what is the definition of displacement? So displacement means the actual distance of a body or object from where it started and where it came to an end. Okay, and in short case we can say that when a body moves from one position to another position, okay, then the shortest, or we can say a straight line, okay, draw a straight line from where it started and from where it came to an end. Okay, then draw a straight line between the distance between the initial position and final position of the body along with the direction. That is called displacement. So in this case, in this diagram, what is the displacement? As it started from A and it came to an end to A only, so the displacement is 0. But if the car should have been stopped here only, then what would be the displacement? the displacement would be 6. Why? Because it started from A and it came to end to this point. So this is the shortest distance as well as the straight line from the initial position to its final position. So it's 6. Okay. So till here we covered the distance and displacement and motion and some scalar vector quantities like speed and velocity. And the rest part of the video we will cover the rest chapter. So thank you for watching this video. If you liked, then please subscribe our channel and like, share, comment, of course. Okay, thank you.